Hi and welcome. This is my oral exam from Analytic Circuits. For this exam, we are planning two scenarios, which in first we have a scenario with a simple circuit with a resistance and a LED. And for answering the first question, we have to know the value of the resistors. For this, we can use the Ohm's law, and that it consists in a formula that can be modified, and actually it's appearing right here. It can be modified to get any value of this. The value is 345 ohms. Here we can see a simulation representing all the circuit working in real time. Next, for this next question, yes, we can use two resistance of different values in the circuit, making it work. Yeah, we just have to put our resistance in series, one behind the other, so it will make the sum of almost the same value as 345 ohms. Okay, this is not perfect. Why? Because there's a difference of 15 ohms that will make that the current passing through is more than 20 amps. This will mean that the lifespan of the LED will be reduced. Now, for a second scenario, we have a defibrillator, and we need to explain several questions about it. First of all, what electrical values must be considered. First, we have to know how it works. At first, there is a capacitor. It's only like a little battery composed of two plates that contains a positive and negative charge, and this is made to release as much energy as it can. So knowing that facts, first of all, we need to know the relations in the capacitance, the storage charge, and its electric potential. So we need that three facts to know how it works. To guarantee that the defibrillator charge in max 10 seconds, we have first to have a good power supply, with enough voltage and current, and consider if there's any resistance between it. We can explain this with a little concept. This is because the voltage is the charge that is released, but the current will explain in how much charge is being released in a period of time. So we can know that the voltage don't kill you by itself, and isn't even the current by itself. We need a composition of both variables to kill you and function in the correct way. If there is any resistance, that will inflate in the current that the capacitor receives. For the third question, I think we can explain it, the voltage and the current, in a different way. For this, we have to notice in the waves. Yeah, the waves. This explains the movement of current. We can see it. We all know it. There's an example right here. You can see it. But we need to know the amplitude. What does it mean? Well, all types of energy are based on waves and its amplitude. The amplitude and size of this wave will determine how much energy is being supplied and the rate that is being supplied. In this case, we are interested in having a big supply in a short period, so it will look something like this actually. Now, for almost the final question, or the fourth question, well, we will use only an equation of discharge of capacitor, is right now here appearing, and we will implement our value of capacitance and resistance, because that is not provided by the problem, and this will be the result. Okay. And now for the final question, the two factors can affect is first a small capacitance, meaning that the amount of charge supply will be not enough to restart the heart and the person will die. Yeah. And the second one is the time. Well, for us, 10 milliseconds to 20 milliseconds just can be a moment. We can just perceive it as a blink in terms of, but in terms of energy, this is a whole eternity. This is because our perception of time is different from the reality, and the time of fully discharged and half fully discharged, it's really immense. Well, in that terms, we like in 0.5000000 seconds, we can have a discharge of 25%, and if we let the charge a little bit more time, well, the capacitor will release all its potential, not only a fraction of that.